Hi, I'm Tamás Szűcs, and my supervisor is Attila Krajci, and I'm going to be talking about the effect of data filtering techniques on reliability. And first, we're going to have to talk about the relationship between correlation and reliability. And now, what you can see here is the uh, relationship of two variables which have high reliability, and you can see that they have a near perfect correlation. Now, when we lower that reliability or introduce some noise into the system, we can see that the data points become scattered around the regression line, and this results in the attenuation of the correlation coefficient. In this case, it went down by 2 points. And now this is an important problem that low reliability can cause this attenuation of the correlation coefficient. And especially in cognitive psychology, it seems to be that many key paradigms have low reliability because, well, historically they haven't been used that much in correlational studies, but more for the comparison of groups. And so this low reliability wasn't that much of an issue for these paradigms earlier. But if we want to conduct correlational experimental studies, then we need to keep an eye out for this reliability, because if we if we show if we can't show a correlation between two variables, or if we show a low correlation, then without checking the reliability, we cannot be sure whether or not there really isn't any relationship to be uncovered, or whether we just can't see the relationship that is really there because our data is noisy and it has low reliability. And we have run into this problem in our previous work when we wanted to examine the relationship between two numerical effects, and one of them, a priming effect, had a very low reliability, around 0. And so we started looking for solutions for problems of reliability, and what we found was that there isn't really any accepted solutions for reliability problems. Some researchers tried different ways of analyzing the data in hierarchical models, or using some outlier filtering and trimming their samples, but ultimately they didn't succeed in raising reliability with these tools. So we needed to try to work out what we can do in order to solve this problem. And what I'm going to be talking about today is how we tried to raise the reliability of three numerical effects using various data filtering criteria, and where we ended up. So we studied three numerical effects, two of which we measured using this paradigm that you can see on the slide here, where in this paired comparison paradigm, the participant was shown two numbers at once and was asked to decide which one was bigger, the left one or the right one. And here, the bigger the numerical distance is between these two numbers, the easier it is for the participant to make a decision, the better the performance will be. And this is the comparison distance effect. So just to give you an idea, when you compare 1 and 2, this is harder. This will lead to a worse performance, as opposed to when you're comparing 1 to 4, that will be measured as a better performance in this paired comparison task. And another effect that we measured with this same paradigm was the size effect, which means that the bigger the two numbers are, the harder it is to compare them, meaning that it is easier to compare 1 and 2 than it is to compare 8 and 9. And so this is a size effect. And the other paradigm that we used was a priming paradigm, where we only show one number to a participant, and they need to decide if it's smaller or bigger than 5. And then another number comes up on the screen, and they have to decide again whether it's bigger or smaller than 5. And the first number was the priming stimulus, and the second one was the target stimulus. And now the greater the numerical distance is between the priming stimulus and the target stimulus, the worse the performance becomes. And the closer they are together numerically, the better the performance becomes. This is the priming distance effect. And so these were the three effects that we measured: the comparison distance effect, the size effect, and the priming distance effect. And now let's look at how we filtered our data. We used three filtering criteria other than not filtering our data. And these were the trials where the participants made an error, which is quite a widespread filtering criteria that researchers use. Another was to filter out trials that were preceded by an error. And we supposed here that these would be noisy trials, because when we make an error and the participant got a feedback from this error, that would break our flow. It would break our routine, basically. And so that would make the next trial more noisy. And so we tried removing these trials as well. And the third criteria that we used was filtering for outliers. Here we used a 3 standard deviation cutoff point. And we also used the combinations of these criteria, resulting in 7 different ways in which we filtered our data. We also used various metrics to measure our effects, to measure the performance of the participants. These were the usual reaction time and error rate, and also we used drift rate from Radcliffe's diffusion model that we calculated using the easy diffusion model of Wagenmakers. And the way the drift rate is calculated is by using the variance of reaction time and the error rate, or the percentage of correct responses. And this is basically a sensitive metric. It attempts to show the sensitivity of background informational processing mechanisms, and thus it basically solves the speed accuracy trade-off that complicates the interpretation of reaction time or error rate data, which can cause some headaches, especially when the reaction time and error rate data show different patterns of results. And by using the drift rate, we can get a metric that more clearly shows the performance of the participant. And our sample consisted of 30 people, 5 of which were men and 25 of which were women. And the mean age was 21.5 years, and the standard deviation was 2.8. And in the paired comparison paradigm, we conducted 720 trials per participant, and in the priming paradigm, we conducted 192 trials. And this data was collected in 2016 in a previous research, and it was collected by PsychoPy. So now turning to the results of the comparison distance effect. On the y-axis here, you can see the reliability from the even-odd split half reliability calculation method. And on the x-axis, you can see the different filtering criteria that we used. And you can see the results for the reaction time, the error rate, and the drift rate. And the error bars that you see are 95% confidence intervals. And so the most striking result, one would say, is that the metric used to measure the performance of the participant seems to have a very important effect on what reliability we get. With reaction times, it's higher in terms of the comparison distance effect. It's higher with reaction times than it is with error rates or drift rates. It's also apparent that there is no combination of filtering criteria that consistently raises reliability, and sometimes filtering really lowers the reliability, sometimes it raises it, but there is no consistent pattern of results here that would suggest that data filtering really had a positive effect on reliability. Now let's look at the size effect and its results. You can see the same here as on the previous slide. There was a big effect of what metric we used to measure the size effect. There was a lot of variability between the filtering criteria used, some of which lowered the reliability, some of which raised the reliability, but there wasn't a single combination that consistently showed that it raised the reliability through all metrics that we used. And let's finally look at the priming distance effect. Here you can see that with measuring with reaction times, it's like below 0 or around 0, the reliability of the priming distance effect. And again, measuring with other metrics, it's different. It seems to be better. It's still bad, but it seems to be better. And again, we cannot see a single combination of filtering criteria that would consistently raise the reliability. Sometimes it lowers it, sometimes it raises it. But again, no clear results show that data filtering raised the reliability. And now to interpret these results, we saw that filtering has a pretty inconsistent effect on reliability. It can even lower the reliability, and that reliability is pretty much also dependent on the metric that we use to measure the performance of the participants. And so our conclusion can be that data filtering methods did not raise reliability, and that we didn't find any evidence that data filtering would be a useful method of trying to raise the reliability of our variables or our data. And so some future directions that might offer some better solutions could be to get new data with more trials. And we started doing that, basically maximizing the amount of trials that we can make participants do by making multiple session experiments with each session lasting an hour and getting a lot of trials per participant. And this seems to provide some promising results. It seems that this way we can get some usable data for the priming distance effect. We can also try to use new analysis tools, because what we did here was to remove trials that we thought would be noisy. And what that does, it does remove the noise, but it also removes the signal contained within that trial. And so another approach to this would be not to remove the trials, but to include the filtering criteria that we used as regressors in a multiple regression model to try to account for some of the noise in the data. And we tried this out, and it doesn't seem to be the solution. It doesn't seem to be the solution. We're going to be trying this out on other data sets as well, or other variables that could potentially account for some noise, but this doesn't seem to be a Hail Mary in this situation. And another direction that we took, or we're going to take, is to test this out on new paradigms, namely the mnemonic similarity task and its somewhat modified versions, which are used in neuroscientific studies to study the component processes of memory, and more closely some processes that are related to hippocampal activity. And there it is imperative that the used tasks and behavioral measures have an acceptable reliability, as fMRI already deals with high levels of noise. And so it's going to be interesting to see what reliability we measure there, and whether or not we can use any techniques or tools to raise reliability there. And thank you very much for your attention, and I will await your questions on Friday.